Hi, my name is Josh Dodge, and today we're going to look at Vedic Division. We're going to look at two styles, Samhita Bose's method for Vedic Division, and then also Arthur Benjamin. And Vedic Division, coupled with the extended form of synthetic division, brings us one step closer to numerical synthetic division. So let's take a look at Samhita Bose's method of synthetic or Vedic division. So it looks something like this. So you have 287. Now, all of these divisors has to be close to a base 10 exponent. So like 10, 100, 1,000, etc. So if I look at 13, so 13 is pretty close to 10. So 13 minus 3 gives us 10. Or I can think of it as 3 plus 10 equals 13. But that's the number that we're going to be subtracting. So, and you're going to see that this does look kind of similar to the step synthetic division, but it's limited. So bring down the 2. Then the next thing you're going to do is you're going to, and then you would multiply. So 2 times negative 3 is negative 6. Add the columns, so that gives us 2. And then do 2 again. So 2 times this is negative 6. And then 7 plus negative 6 gives us 1. So the answer would be 22 with a remainder of 1. Let's look at the next one, and we're going to have to give ourselves a little space here. We're going to look at do the same thing as before. And by the way, this is a negative digit right here. Let me just point that out. This is a negative digit. So, and I looked at negative digits in the previous video. And negative digits appear in synthetic division. Right, so let's look at this one. You could see 113, and that is 13 away. 113 minus 13, that gives us 100. 13 away from 100. So here you would subtract that. That's a negative 13. And then on the top, you got to give myself plenty of space here. On the top here, you put 13,985. I'm going to bring down the 1 like this. Again, give myself plenty of space. So it's negative 13 because I'm doing 1 times negative 13. So that would be 2. You just do the next column. And then 2 times negative 13 is negative 26. And make sure all these line up. So 9, negative 3, or plus negative 3 plus a negative 2 gives us a 4. And I think I'm pretty lined up. So a little off, a little bit. Let me just space this out. That 6 should be underneath the 8 like that. Right? See how they line up here? And so, and then we multiply, right? We just did the column, so we do 4 times negative 13, which gives us negative 52. Negative 52, like that. And then add the columns. This is going to give us a negative number. That's fine. We'll look at that in a little bit. 5 minus 2 is 3. 8 minus, this is 11 right here. So 8 minus a negative 11, or sorry, 8 minus 11 gives us a negative 3. So that's negative 3. Now, here, the remainder, it matches what you have here as to the divisor. So notice here on top, the top example, that the divisor is 1 unit. So that means the remainder is 1 unit. Here, what you're using for the divisor is 2. So this should, the remainder would be 2. So here you have 124 with a remainder of -3, -30, +3. Well, we got to fix that. Can't have that. So we're going to borrow from the quotient. And so that would give us 123. And then the remainder, we're going to add. So when we add, so you're going to do 113 minus 30 plus 3, which is pretty easy. That would be 86. So the second one is 123 with a remainder of 86. Not bad. Vedic division is pretty cool. With submitted Bose, you do see a limitation with being close to 10 or 100 or 1,000, like I said. All right, let's look at Arthur Benjamin, the math magician himself. So this is going to look different. It's going to look like more like long division. So you have 26,763, 58. Now 58 with this particular method, you pick a number that is close to 58. So like 60. 60 is close and it's close by 2. So 58 plus 2 equals 60. Now, what you're going to divide by is by 60 or by 6. And then you're going to use 2 right here as the multiplier. So we're going to look at 26. 6 goes into 26 4 times, and he calls it short division with a twist. So you're actually going to do some short division here. So 4 is 20. 4 times 6 is 24. So that's going to have a remainder of 2. That goes in that next column there. You're going to divide again, but this time you're going to use a multiplier. So the way that works is you have 27. Take the previous number here, which is 4, but you're going to multiply by 2, so that's 8. 8 plus 27 is 35. And then divide by 6. Well, when you divide by 6, that is 5 with a remainder of 5. And then you're going to do the same thing again. So with 56, so 56 and then 2 times 5, which is 10, is 66. 6 goes into 66 11 times, so 11 times, and the remainder is 0. And then you stop, so the remainder, so 3, and then you have 11. So 3 and the 11 you have to multiply by 2, so it's 22 plus 3, which is 25. So the remainder is 25. Now, the way that you would put your final answer, this is 4, 6, 1, and then a remainder of 25. So the final answer would be 461 with a remainder of 25. I think it's pretty cool. It's pretty nice. Can get lost with the multiplier, and it's only limited to 2 digits. So let's review. So some of the weaknesses in Vedic division is, well, with the first method, you saw that it had to be close to like 10 or 100, or I didn't show you 1,000, but you could use 1,000. It had to be close to a base 10 exponent. The second method, and Arthur Benjamin does a really good job, but with his method of Vedic division, he only limits it to a two-digit number. And for the most part, when you're working with division, you can do a little rounding or whatever and get away with dividing by a two-digit number. But he only limits it to that. So there needs to be something that's better. And again, this brings us one step closer to numerical synthetic division. In the next video, we'll look at the extended form of polynomial synthetic division, and you'll see how that brings us even closer to numerical synthetic division. Check out my article and sources below, and I hope you have a wonderful week.